Welcome to this presentation of the Four-Quadrant Dynamometer power supply. As the technologies for electromechanical devices are more refined than ever, along with a growing interest for renewable energy over the last years, LabVolt's team has decided that the time has come to present a brand new multi-purpose dynamometer doubled with a versatile power supply. We proudly present the Four-Quadrant Dynamometer power supply, model 8960-20. Packed with more than 20 functions from the constant torque prime mover to variable frequency and amplitude power sources, the 8960-20 is an unmatched ally when it comes to teaching electromechanical and renewable energy. The front panel features a function selection button, a start-stop button, and a command knob to adjust the desired parameter. It also features two analog outputs for speed and torque measurement, along with shaft encoder outputs, a thermistor input for temperature measurement, and an external analog command input. As you may have noticed, the 8960-20 is also equipped with a USB port, allowing the connection of a computer for outstanding capabilities. But first, let's talk about the basics. Since this module can be used as a dynamometer or as a power supply, characteristics related to both modes will be discussed in this video. Rated up to 500 watts, 150 volts, and 5 amps, the power supply mode provides you with positive and negative voltage and current sources, along with AC power sources and a lead-acid battery charger. It displays precise measurements of voltage, current, and electrical power. Do you need a dynamometer? The 8960-20 contains a permanent magnet DC motor generator that speeds up to 2500 RPM with a magnetic torque of up to 3 Newton meters. Its mechanical power can go as high as 350 watts, close to 1/2 horsepower. Using this mode, you can find functions such as constant speed and constant torque prime mover in clockwise and counterclockwise directions, along with a 2-quadrant constant torque brake to apply a mechanical charge on a motor. With all these functions reunited, true four-quadrant operation can quickly be demonstrated. In dynamometer mode, the front screen displays the speed, torque, and mechanical power in real time, measured at the shaft of the machine under test. An internal compensation function automatically compensates for the losses due to friction in the bearings, belt, and windage, assuring accurate torque measurements. Both power supply and dynamometer modes can supply and sync power from an electrical or mechanical source, which in this case automatically returns the excess power to the electrical grid at a unity power factor. You heard it right. The 8960-20 helps energy conservation by returning mechanical or electrical energy it receives to the AC power network automatically and at all times, making it a true green appliance. So far, all the functions we have talked about are accessible using the 8960-20 in standalone mode. Is this enough for you? Well, it isn't for us. To add various optional functions to your 8960-20 and extend its capabilities, we have added a USB port, which allows the user to perform complex functions using our free LabVolt software. We call this mode computer-based mode. Bringing the 8960-20 into the modern age, the computer-based mode allows the user to completely control every function we already saw and much more directly from the computer. Using LabVolt's free LabVolt software, you can record all these parameters into a data table with a single click. In fact, using LabVolt's easy-to-learn control window, the computer-based mode unlocks access to new functions such as speed sweeps, an automated function that steps the speed of the prime mover over time. This is a perfect function to draw a fast speed versus torque curve of a motor. It also features nothing less than 5 variations of nickel metal hydride battery chargers with a battery discharger, ideal to study various charging techniques. Do you want more? We have something left. Paired with the processor of a computer, the 8960-20 is able to faithfully reproduce the operational characteristics of a small wind turbine, a hydraulic generator, and solar panels. Using the transfer functions of a real wind turbine, students can emulate with great precision the true behavior of a wind turbine under various wind speed and air density conditions from the comfort of a classroom. Coupled with the wind turbine generator and controller module, Model 8216, this function is capable of covering the entire process of energy generation from wind power. In power supply mode, the solar panel emulator offers the opportunity to set parallel and series combinations of solar panels of various sizes. While controlling the solar irradiance, students can study the behavior of photovoltaic cells under a desired solar condition and quickly collect realistic data without bulky and expensive specific light sources. Don't forget that a hydraulic turbine emulator is also available, that MATLAB and LabVIEW can be used with the 8960-20, and that emulators and functions are still in development for the near future. Combining power supply, prime mover, dynamometer, metering, and emulator properties, the 8960-20 is a state-of-the-art multi-purpose device you will keep referring to, whether it is to charge batteries, run stress tests on a newly acquired motor, or accurately emulate the process of energy generation from wind, solar, or hydraulic power.